So everybody's been asking me about different provider integrations for Effect, and we've got I've got a PR open for uh, if we take a look, I've got a PR open right now for where is it? Amazon Bedrock. So hopefully soon we'll be adding support for Bedrock. The features I have in here are limited at the moment, but I figured better than nothing. Um, And people have also been asking me a lot about Google Gemini. So we are going to be seeing if we can. Um, we're going to see if we can hack together a basic support for Google Gemini. Um, One of the things that we need to do first, though, is we have in like our AI packages. If we take a look, maybe like OpenAI, we use Tim's open API generator to do code gen for like against the provider's open API specs. And so by doing that, we save ourselves from having to manually create all of these different schemas ourselves. For the Bedrock integration, I actually had to manually create all these schemas, which was a pain because they don't expose an open API spec as far as I'm aware. I think they have some other they have a Smithy spec, I think, but I don't really have a good way of converting that into what I wanted. So I just manually did that one. But Google does have a open API spec. So if we take a look at some of the work I've done so far, we're basically going to use Tim's open API generator to code gen as much as we can here. And I know he just released a little patch last night based on a request that I had. So let's see if we can get the updated package in here. We'll just do it for all of these. And maybe we'll update Mattia's language service at the same time. Oh, I forgot to click it. There it is. So one of the problems with the spec that Google publishes is kind of weird. You take a look at their open API spec and look at the paths. So for every single literally every single endpoint, they only specify a default success response, which if you actually look at the open API spec, I can kind of show you folks. Open API default. This one? No, this one. Not parameters, paths. Responses, default responses. I'm going to turn the music down a bit. So it's kind of weird. Usually in an open API spec, you would specify based on the response code, like what schema you then expect for the content that's returned. So this way you can like clearly delineate like what happens in a success case, what happens in an error case. But Google and the default one is used as kind of like a fallback. So usually folks will either use this for describing like errors that can happen in any other case other than a 200 or whatever. But Google's spec is kind of strange in that it only specifies a default, which we interpret as they always expect to succeed. Otherwise, it's like a I guess a defect, but still kind of strange. So Tim released a small patch to the Open API because the way when I was actually doing the code generation for this, if we look at the generated file I was working on, and we go to the constructor for the generated HTTP client, every single response is just a fallback, is literally just an unexpected status response, which means that for every operation, I'm just getting an effective void or like errors, which obviously is not correct. Like this operation we just saw, based on the spec, should technically return a permission object. So anyways, Tim released a small patch to basically say that if a default is the only thing that's specified, it'll generate as like a, I think this, to whatever the default is, and then have the or else be the unexpected status. But one thing I want to do is save this as a backup because I did have to manually massage one of the schemas, which was self-referential. We'll take a look at that in a sec, but I want to run the code gen. So let's go to packages AI Google, and we'll do a PNP, or we can actually just do. Okay, so let's take a look at the constructor. And why is this complaining? Not sure why that's complaining. My suspicion is it has to do with the issue that I fixed on this side. So if we go to the class schema, so this particular object is self-referential in the items and in the any of field. And we can fix it using a little bit of trickery. So if we look at the generated backup class schema, so the first thing we do is we create to fix this like self-referential error. The docs go into this, but we can fix this by first extracting all of the fields that are not self-referential. So we can do schema field. And the other problem with this, by the way, is that the encode, so self-referential errors or self-referential schemas that have the same encoded and decoded type are actually really easy to deal with. You just wrap the self-referential part in a suspend and you annotate the type as like schema.type. When the encoded and decoded types are different, you have to do a tiny bit more work. So we'll show how to do that here. First, we copy up all these fields. We delete the self-referential ones. So now we've got this like schema fields object. And then we need to create an interface for the encoded type because we need to manually annotate the type so that TypeScript doesn't barf at us. So we'll do a schema encoded extends s.struct dot coded type of schema fields. And then we can come in here and delete anything that's not self-referential. Okay. And then we can spread in the schema fields. And we can do this schema.suspend schema. Sorry, this should be S. S.suspend. This way, we solve one of the first problems, which is making sure that the actual like runtime value is lazily evaluated. So we don't just get like infinite recursion. And then we need to specify the type, the encoded type that we're expecting for items in any of. So we can do items key only. I'm just going to keep it like this, and it's going to be schema encoded or null or undefined or null, and any is going to be a read-only array. So again, all we're doing is we're just trying to extract the problematic types. Oh shoot. What is up, all of Dylan's viewers? I was literally just in your channel 10 minutes ago. How goes it? Let me know if you guys can't hear the music, because I still haven't figured out how to get that to work. Okay. For the folks that just joined, we are working on a Google generative AI provider integration for the Effect AI packages. I mentioned to everybody, no music, so should be okay. I kind of wanted the music to play. Whatever. I'll figure that out another time, I guess. How do I get that? What can I connect to? Sorry, guys. I wanted the music to be playing. Anyway, I have a PR up that's going to add support for Amazon Bedrock, basic support for Amazon Bedrock to the AI packages. Hopefully we'll get this in soon. And in the meantime, I'm also working on a provider integration for Google's generative AI, because a lot of people have been asking me for Gemini support. So right now we're just generating the schema from the Google OpenAPI spec. And we're just dealing with a small issue related to the schema generation. So anyways, when you have a recursive effect schema that is different in its encoded and decoded types, that's basically what we're dealing with here. So we're fixing it. The first thing we did is we extracted all of the non-referential schema fields into a separate little object here that we're spreading in. And then you have to specify the type of the encoded side of the schema. And then once you've done those two things, spread in the fields that are not self-referential. And then you can do this s.schema, and we specify the type of the decoded and the encoded. Whoops. And hopefully this will work. Whoops. Give the LSG a chance to catch up. No problem. Maybe move the schema part to a new file so you can keep regenerating. I probably will. What I'm actually going to do is I'm going to do what I did with OpenAPI, the schema generator, which is, if we look at what I did here, I had a patch that I needed to apply after generation here. So I'm going to do the same thing. I'm going to basically create a diff and then apply the patch as part of the generator script. But for now, so we fixed the schema type here. And the other reason why we don't like separate these out is because we try to keep since the code gen is dumping everything into a single file, then we only have to ignore a single file from like our documentation generator and everything like that. Like this generated file here. But anyways, so this should fix that issue. And it looks like we have one more. What is this? We're not using decoder, so we can get rid of this. And this should now be fine. Oh, okay. Yeah, no diagnostics. Okay. So we can delete this backup. And now what I want to do is I want to make this into a backup and then do a diff on it. Let's see what I did for OpenAI. I forget how to create a diff. I have to look. Create a diff to apply with Git. Right. You can use Git diff to produce a unified diff suitable for Git apply. Can I just Git diff G files? Well, anybody know how to generate a diff of 2 files like this? I forget what I did here. All right. Well, I think we can use git diff, and I'm pretty sure we can just pass the 2 files. So let's try that. First thing we'll do, we'll make a backup. Again, we will run the generator again. Cool. And now we should be able to get diff get diff source generated. Where are we? Get diff source generated source generated .back.ts. I think, what's the output flag? I think I can literally just redirect this to a changes patch. Did it work? Cool. This is a big patch because the ESLint's not working. That's why. Let's fix it. Counts. Kind of want my patch to be small, so we can fix it by first deleting this line that the ESLint has a problem with, letting ESLint format, reintroducing this, closing that. Probably still going to be like a reasonably large patch, but let's see. Yeah. Okay, so we're going to call this fix recursive schema type. And we're going to move this into here. And then we're going to go to OpenAI scripts, generate scripts, generate. We're going to do that. And we're also going to do this. And we need to fix this. It's in theory, this should work. It might not. Actually, let's find out. We might have to generate the patch since ESLint's not working anyways. We might have to generate the patch without ESLint formatting. It's fine. Let's just see. Source. Let's do the generator. Yeah, we have to apply the patch and then run ESLint. Okay. So git def changes that patch. Sorry if people have been chatting. For the people who followed Caleb C. Films, Reco, 13 Troll, and Vafi, thank you very much for the follows. Caleb, how long have I been using Vim for? I don't know. A year, maybe a little bit longer. I was using the Vim plugin in VS Code before this. I was using the Vim plugin in VS Code before this, and then I got NeoVim pilled. I think maybe by Dylan. I don't remember. But at some point I got NeoVim pilled. Just started using Vim and Zed for like a month and I've been loving it. Yeah. I have like this sick obsession with configs. I really like being able to tweak configs. And so NeoVim really feeds into that obsession. So all right, let's try this one more time. Patch does not apply. Just git add the file, then regenerate, git diff. Yeah, we could do that. Let's do it that way. Hey, Josh, how's it going? If you're not using git to manage the files, but still want to create a patch, you can apply. That was the command. All right, let's do it again. Let's comment this out for a moment. Regenerate. Okay, we should have. All right, let's get rid of the swap file problems that NeoVim's having right now. Let's delete this. Regenerate one more time. Open this one. First. Let's just shut down all the buffers. Generated. We want this one. Okay. All right. Just seeing some great developer working on a thing, which will take ages for me to start with. I hope you're not talking about me. This would definitely not take you ages. Right now, you're watching a very average developer struggle to create a patch file. Alrighty. diff-u source generated dot back. I appreciate that. Thank you very much. So yes, it's very nice. Okay. How did I do this with the Open API one? Did I really like commit it and use git? I swear this is like way harder than it needs to be. I did diff git, and I literally just ran it. We're asking our friend ChatGPT. Diff git lines of parent patches generated by git. Okay. Let's try what Donnie said. I don't know why I'm doing it this way. To okay, the generated file is staged. Will this work? Git diff cached into the patch. I think that's the wrong command. Git diff. I want to generate a patch file for a single file from the last commit. Okay. Diff head. See, this is the command I ran. Okay. Head source generated changes.patch. Okay. This looks much better. Great. So we should now be able to go to our script, copy this file name. Hang on. Copy this file name. Add it here. Great. And now in our generator, should be able to do this. Hopefully this works. Maybe we just do the smart thing and quickly scripts generate. I'm sorry, I wasn't looking at chat. Do you need to get add first or use without cache? Yeah. Patch failed to apply. All right. Well, I'll figure out how to automate this at a different point in time. I don't want to waste too much time on this. what I'd like to do is get more into the code. All right, so maybe we can use this as sort of like a semi-tutorial on the way that I create providers for the AI packages. I mean, the AI packages are still like somewhat in flux in terms of their API. I think we're on the 3rd rewrite currently. But I'm just gonna quit a few of these things. The providers themselves haven't they don't change too much. Most like they change based on the changes to the API in the base package. So I feel like if you're creating a provider, the steps are mostly reasonably the same. Usually the first step I take is to create a client for the provider. So clients are services in effect. So first thing we need to do to create a client service is create the context tag. So we're going to call this the Google Generative AI Client. And that's just in keeping with the same naming theme as like what we're doing with OpenAI and the other providers. And then generally speaking, I'll have like a service interface that I expose. So we use a declare namespace to keep this type only. And maybe we can just keep the OpenAI client open to take a look. So you'll see the OpenAI client is very similar. The service interface will say like what fields the client's actually going to expose. So you see up here, like on the service here is the actual shape that you're going to get when you yield this service. So here we can use, let's delete this and just use the correct one for now. And we'll import everything as generated from generated. And Tim's generator will also generate a type for us for the client. So this client interface has like basically the types for every single one of our the methods that we can call on the client, which is really useful. And we expose this. So like the idea is if there's a particular functionality that the AI SDK that we're providing doesn't currently support, for example, like OpenAI's like files API, if you wanted to like upload a file, you can actually yield the client in your effect program, access the underlying client, and use that to interact over HTTP with OpenAPI or whichever provider you're using. Okay. So I did start like scaffolding some of this out so we can take a look at it together. So we've got a constructor here for the service. So we've kind of got like the service definition here, but now we need a way to actually build this service. So we're starting out with a constructor for the service, and then we'll turn this constructor into a layer constructor in a minute. The constructor at the moment is just taking an API key, so you need like a Google API key. Am I streaming through Microsoft Teams or something similar? I am streaming through Riverside right now. Why? Is the quality poor or? If it is, I can look into setting up like OBS and everything like that for myself. I just didn't want to do that if I didn't have to. So we've got an API key that we can take in. We've got an API URL that we can override. It's going to default to the generative API URL. And then all of our provider integrations allow you to transform the underlying HTTP client. So the first thing that we actually do inside the service here is we build up an HTTP client, and maybe to make the code a little bit clearer. Oops. not what I wanted to do. The first thing that we do here is we actually start to construct an HTTP client. So we grab the HTTP client service and then we map the request. We need to do a couple of things to modify the request. The first thing we do is we prepend either the URL you give us or we default it to the V1 beta, in this case, the generative language Google API URL. We set the API key header. One thing I need to make sure I do is look into how I can make sure that any headers that I add that are custom that are not already redacted get redacted. So we add the xgoog API key header. Instead of like all of the examples for the Google generative language API show putting the key into the URL, which it's not very secure. So we're going to use this header. And then we say that the request, basically we add the content type JSON header. And then once we map the requests, we still have a client that we're dealing with here. And so we can basically, if you specify a transform, we then add that transform onto the client. So you can use this to add like custom headers, or I don't know, if you've got like a proxy service sitting between your client application and then like the underlying provider you're using, you can transform the client to add headers for your like proxy service or whatever. And then we have this HTTP client OK thingy that basically makes sure that the client will error on non-200 status codes. Nothing is wrong. It's just the layout I'm not used to. Yeah, at some point I need to set, if I'm going to stream more regularly, I need to set up like OBS and do this properly. But the mic sounds like it's coming from your headphones. It is also something I need to fix if I'm going to stream more regularly. I mean, if you guys would like to see more regular streams, kind of like what Dylan does, I can try to get on more of a schedule. And I can get my setup a little bit better. Okay. So let's just crack open the Open API client. I want to make the font just a tiny bit smaller, if that's okay. Okay, so then we can, now that we've got an HTTP client in here, we can actually construct the final client. You should do it. All right, I mean, if folks would like to see more stuff from me, just doing like effect development, I'm happy to do that. So we're not going to use the HTTP client OK client in our generated client because the generated client already handles like success and error cases for us under the hood. It handles both 200s and anything greater than 200. The only case where this will be relevant, this client that we're filtering on status codes, is for streaming use cases. And we'll see that when we start like looking into adding streaming support to this particular client. But for now, the generated client, we don't have to worry about that. On the OpenAPI side, or OpenAI side, there's this OpenAI config thing, which you can use to do per request transforms. So the transform client thing here transforms the entire HTTP client. But we had a request at some point where somebody wanted to be able to add additional fields to each request and customize it on a per request basis. So we support that by basically allowing you to pass a custom OpenAI custom config per provider. And one of the fields on that config is another like transform client thing. So we'll set that up in a second. Here with transform client. Why can't I type today? But yeah, if you folks enjoy the stream and whatever, I can get a little bit of a better setup going. for sure. So let's go ahead and literally just copy verbatim this config, and we could do Google generative AI config. Config. And we can just edit this Google generative. Actually, let's do the open AI config, Google generative AI config. And let's just double check that worked. So again, the config is just another service. At the moment, this thing just has a transform client method you can specify. And then we have a helper that kind of does the dance of checking if the service already exists and overriding it if we need to, or just providing it. So like you can basically if you're using the Google client, you could just do like Google generative AI config dot with client transform and specify your transform there. And then if you're using the Google service, like if you're using this provider, this transform would be applied. Transform. Otherwise, it just would be ignored. So it's kind of nice. And we can add additional like configs here over time, but that's what this get or undefined thing does. It basically grabs the current effect context out of like basically the full effect environment and tries to get this service, otherwise returns undefined. Anyway, now that we have that, we can go up here and we can do import everything as Google generative AI config. Weird. And then down here, we can copy what we did here and apply the same thingy. I guess I was importing like this. Yeah, so now what will happen is on every request that's sent to the Google Generative AI API, we'll check if there's a transform client method specified in the config and apply it if there is. So this way you can do both like full overrides of the client so that you're always sending particular headers. Or you can just do partial, like per request overrides. Let's skip some of this for now and just do this. Return Google Generative AI client. Oops. .of client. And this, for anybody who doesn't know, the context tags have a special like .of constructor, which is basically just a way to allow you to have type safe. I don't know how to say it other than like it's the same thing as doing something like this: identity client Google generative AI client.service. It's the exact same thing, but it's kind of just like it's basically a type safe way wrapper for just returning the object itself. For anybody who didn't know this existed. And then we can create the layer. So let's go grab the options here. Export const layer equals same options. You want to grab this. And this is going to be a layer. that returns our Google Generative AI client. It has a config error and it requires an HTTP client. And these things here, like these parameters, the type parameters, we always try to annotate types from our library methods because just helps with TypeScript. If you were doing this in like a project yourself and not library code, you wouldn't need to annotate it. But if you're curious where those come from, the make constructor has similar type parameters. We have a make constructor that's going to run an effect that's going to produce us a Google Generative AI client. It's going to never fail, and it's going to require an HTTP client. And the reason it requires an HTTP client is because we're yielding it right here. And then we just use the layer constructor, layer.effect. We specify the tag, which is Google Generative AI client, and the constructor, make options. Cool. Maybe we can make this a little prettier. And there's one more thing we need to do. This is actually wrong. This one is a never. The layer config variant is the one that takes so our client's exposed to ways of creating layers. One is just if you pass the raw values themselves, and then one supports config, the effect config module, I mean. So we can say options config.config.wrap. And the wrap helper just basically takes all the types in here and conveniently wraps them up into a config parameters. So we can do config, and the layer that we produce in this case is going to fail with a config error. And that's because we're going to do a config.unwrap options. Because if we look at the options type here, this config wrap thingy is a type helper that takes all the properties in here and wraps them into configs. This way you can pass them that way. So we're going to unwrap, and then we do an effect dot flat map make. I think this is what I do over here. Yeah. Layer dot effect. Open a Google Generative AI client. Cool. And then we can grab the JS doc. So with that, we've got like the very basic scaffolding of a client, like a provider client. Basically, most clients, since they interact over HTTP, I think all clients interact over HTTP, really all you need is an HTTP client that's capable of talking to said provider. And then like most of our providers also have methods exposed from the clients that assist with like streaming. Since streaming is kind of a special case for most of these providers. But really the only fancy stuff we're doing here is the generated stuff, like generating an HTTP client as opposed to manually specifying one. If you want to see an example of manually specifying one, you can look at the Bedrock PR I've got up, where we actually do manually specify this client. So again, all of the ceremony is the same, but the client is actually manually typed here. And you can see like how we create this client manually here. There's still a little bit more work to do on this PR, but most of the stuff is in here already. All right, let's see. Transform client. I wonder if we can use this to inject the updated redacted names, or if we should do it here. Let's see. What type are we working with here? I think this is just an HTTP client. Yeah. So I wonder if we can. Well, an HTTP client, if I remember correctly, is just an effect, maybe? No, it's not. I'm basically trying to figure out where I can redact certain headers that I want to redact, so that they don't get printed. I think doing it here makes sense. Maybe. I think we have a method that does this effect. Platform. HTTP client. Error handling filters. Don't think we have. I could be wrong. I don't think we have anything on the HTTP client, but maybe on the request. Combinators, constructors. No. I know we can add to the current redacted names, so that's probably what we'll do. We'll probably just do a Fiverr refs or effect that locally headers dot current redacted names locally with. Is this the one where I can? Yep. All right. Dot append x scoog API key. I think this will work. I think. No, we'll test it out later. We'll leak some API keys for you all to take. All right. Let's do some more interesting stuff now. Let's take a look at the actual like Google generative API. Google generative AI developer docs. Generative AI overview. Documentation. So I don't know if we want this specifically. Google Gemini AI or docs. Here we go. Okay. Yeah, so this is what I was talking about before. I did not want this to do this. I wanted to specify the API key as a header. So that's what we're doing. Let's look at streaming because that's the last piece we need to finish fleshing out this client. And Is it on the API reference, maybe? Text generation, streaming responses. By default, the model returns a response only after the entire generation process is complete. For more fluid interactions, to use streaming to receive generate content response instances incrementally as they're generated. Okay. Stream generate content. Guess we'll have to figure this out. Const stream equals what do we have generated here? Generate. I guess we'll try this. Because for the open API one, I know. Yeah, we were basically this is just like a type helper that omits the stream property from the request, but let's try this. Instead of doing this, we'll stream suspend. And let's import stream. Okay. We're probably also going to need something like this that actually sends the request off. We can also double check in here. Stream, anything with streaming. Generates a streamed response. Ooh. Stream generate content by dynamic ID. Stream generate content. Let's look at the API reference. Generating content. Text generation. That's not what I wanted. Stream generate content. Yeah, so I think we might be in luck here. The open API spec might already have specified this for us. Stream generate content. Stream generate. Cool. Generates a streamed response from the model given an input of generate content request. That's exactly what we want. That's fantastic. The return type of this. Yeah, I respond. No, this one. Oops. A stream of a HTTP client error and never. Well, that's exactly what we have here, except we also have a parse error we have to deal with, but that's okay. That's awesome. Let's try it. We might not need this. Unit deployment never used. All right. Let's go into our trusty Scratchpad. And we'll set up a little script we can test with. Might have to fix this a little bit. PNPM code gen. We have to do that. Actually, let's go back to the root of the. What else did we need to make this work with Amazon? I forget. You need to add it to. We simplified a lot of the configs in our repo recently, but I'm still not used to it. So, AI, Google. No, don't do that. The TS config also needs to be updated. I think detest is fine. Is there anything I can do in package JSON? I forget. Don't think so. Inside Scratchpad, I think I need to add it as a dependency. And then I think I need to do a. Actually, is there a PM? PM, please. And then rm-rf node modules. We're basically just trying to get set up to be able to run some Scratchpad tests here. And we should be able to pm install. See if this works. You folks are eerily quiet in chat. Okay, that worked. Nice. Let's also import effects. Let's program. We're going to grab the client. This is not how you would typically write AI code with effect, but we don't have an AI language model or anything like that implemented for Google yet. So we're literally just testing the client. Actually, this is interesting. What is the return type of? What is the return type of? I think the return type is actually wrong for that method, so we may have to. Stream. Yeah. Yeah, so even though that sucks, even though the this exists as a method that we can issue, it doesn't return an effect stream, which means we need to do it ourselves. So back we go. And we are going to need a stream method. We can actually use this one as inspiration, because I did a lot of this work for the Bedrock client. We'll do something very similar to this. So there are two methods implemented here. Stream request gives us the raw response stream, and then the stream method gives us the response stream that is a stream of AI responses. Generated dot generate text response, and this is going to be a client. Sorry, this is going to be in the HTTP. This is why we need this one. HTTP client. Okay. Dot execute. Actually, let's text request. It's something. Client dot text stream generate content. This. Yeah. Sucks. Okay. So we need to look at what we did here. So we created our own client. Basically, we issue a So this is not going to be as relevant. Okay, so basically what we're trying to do here is we need to create our own streaming request. We can't use the generated client, basically. So we're trying to create our own version of this. So what we're going to do, get rid of all of this. Get rid of all of this. We need to do HTTP client request dot post. Put it in here. We posted to this. Bring this over for reference. So we need to post to this. We can look at stream generate content also for inspiration. Here we go. So we're going to go to V1 beta. We actually need to fix models. Request.model. Yeah, really not in the generated text. Yes. Excuse me. Stream generate content. Alt equals SSE. Model. Enter requesting encoded. Okay, model. Okay. Requests or options. Yeah. Pipe requests effect.org die HTTP client request. And how do we do here? We do HTTP client request dot body unclear JSON. So we're going to take in the options as the body. And then we're going to do an effect flat map because we need to manually apply the transforms request. Back to start flat map again. Apply client. Well, where did this come from? Oh, we're actually going to need to do this. Shoot. Right. We create the request, we apply the client transform, and then we use the client to execute the request. Okay. So let's do that. Let's change this to an effect dot functions. Make this a little easier to see. Function untraced. Function. We're gonna use generators to make our lives a little easier here. This is going to be a function that takes in a model and the generate text request, and it's going to produce it's going to actually execute the request. So first thing we do is we generate the request. So request is equal to this. This URL. We're going to post to this URL. We need to fix the base API URL to not include v1 data. So this will create an HTTP client request for us. Then we need to apply the client transform to the request if it exists. So we are going to do this. Const config equals yield. And this will either give us the config or not. You can even do that up here. If config predicate of is not undefined. So if we have a transform client method in this config, we need to apply it to this custom request thingy that we're building up here. So the const client equals this. And then we do config.transform client HTTP client. Otherwise, we just return the HTTP client. So we've got a client, we've got the request. Let's move this over here. This feels like it makes more sense. We are going to do this for the full method, so we can just put that down here. Okay. So we've got a transformed client if we need to transform the client. We've got a request with the correct body, I think. And now we can execute said request. Let's just assign it here for a second. Where client.execute request. This returns an effect with a response or never, right? And the streaming content generation expects what? What does it return? It generates a stream of generated content response instances. Okay. You look at how this is used up here. Yeah, I mean, we had to do something a little special for AWS because of the way they stream their events back. We had to create an event stream encoder, but I think here we can do flat that response. This will give us a stream. I'm sorry, effect.map. This will give us a stream of binary information. And if we look at OpenAI client, yeah, this is like a little bit of a brain teaser. We're actually going to want the HTTP client okay here. This, then we can do a stream.unwrap scoped. You can re-import stream. And now we should be dealing with a stream. Right? Yeah, stream. That's going to return our binary data or an HTTP client error. And now how do we decode this? Well, we could just run this and see what comes back. I mean, if we're getting server sent events, what does this mean? Let's look at this notebook. Set alt important. Set alt SOC in your URL parameters when running the curl command below. With SOC, each stream chunk is a generate content response object with a portion of the output text. Let's try this. I'm pretty sure I have my API key in the environment. So let's see. Okay, if you stop that, yeah, each piece of data that we get back in the server sent event, in this case, is a full like response. But I don't think we want that. I think we want to do better. Let's see what it looks like without this. Oh, I see. Literally, like without that, you get back like the, it looks like the full object every time. Or pieces. And how do we know when it's done? Man, their docs are just god awful on this topic. Let's see. Uh, du- du- du. Just taking a look at some other documentation on the topic. I think we're going to want the SSE stream. I think we're going to want this version here. I'm going to do a HTTP client request set URL param. Let's do alt with a C. And then I think we can follow this to some degree. I forget where this one, experimental. We just need to figure out how to signal to the stream that it's done. Let's just how do we know when we're done? Let's see. Stream generate content, generates a streamed response. Streaming responses. By default, the model returns a response only after the entire generation process is complete for when the streamer is. Okay. But how to know when done? Well, let's go back to our scratchpad. Oh no, we were just running curl. Tell me a dad joke. So why don't eggs tell jokes? They'd crack each other up. I guess we know when we're done based on the finish reason, which is fine. If there's a finish reason, then we know we're done. All right. Takes while, take until. How do we do it with Bedrock? What did we do here? So we don't do anything. We just run the stream. Stream request, and then we filter map the stream. And we just let it finish. Okay. That means we don't need this. Well, don't need this. We don't need these, but what we do need stream dot map effect. We could probably do map chunks. Try to make this a tiny bit more efficient. What is the event shape? Event ID data. I think in this case, we just have data. All right, so we'll make a const decode. Actually, let's do it out here. Decode stream response. I don't know. Schema dot decode unknown. Schema dot count. Schema dot struct. I don't think we need chunk. What we do want to do is maybe stream.map event data, which is going to be a string. And then we can JSON.parse it. And then here we should have chunks of like any or unknown or whatever, and we can probably just do a decode stream response, because what we're going to do here is have a chunk of generated dot text. What was it called? Generate text response. That's what this thing says it generates, right? Generate content response. Generate content response. So yeah, this should now return a parent yield. All right, actually, you want to. You can't use effect.fm here. we got to do. When we can, it just would require us to unwrap the stream another time, and I don't want to do that. We need to use. Oh no, that's fine. We're gonna have to do it anyways. Um, Now, this is fine, but it does unwrap the stream twice, so I kind of don't like that. It would be better if we could just write this as a function. Let's see if we can do that really quick. Google get around to find that pipe. Well, let's just see how this goes. Getting request. And what's the type of this? Well, let's see what we want the type to be. So we want stream request to be a function that takes in a model and some options, which are the type of generated dot heck, why can't I? I don't know if this is actually correct. Generate text request. Request body. Contents, tools, tool config, safety settings. Let's double check. Stream. Yes. Generate content request. Type of generated dot. And this is going to return a stream of type of generated, generate content response dot type, HTTP client error. All right, there's a parse error in there too. And now we should be happy. Okay, so now that we do that, we should be able to go back to our scratchpad. And run the same yield client dot stream request. We should be able to run the same thingy here. So this model with contents, parts, right? No, content. What's the type of this? contents, which is an array of parts where we want to say text, tell me a bad joke. And this should return a stream, which we can then pipe off of and do a stream dot run for each response. Anyone alive in chat? Model is missing. Well, we're passing model in manually. Does that mean we don't need this? Just do this? Oh, nice. We don't need to pass model in. We can pass it as part of the request object. Still here. All right. Well, I'll have to certainly improve my stream setup so that you guys can have music and request music. You do like something like what Dylan does. I really like the vibes on Dylan's stream. It's good vibes. Okay. So now if we go back to the Scratchpad, I swear half of like building these providers is just figuring out all of the quirks of their individual APIs. And now we should be able to do model. This one. Somebody is at my door, folks. I will be right back. All right, folks, I'm gonna have to wrap this up pretty soon. So let's see if we can at least get the responses from the client working. So this should now be our response. And let's just, I don't know. For now, we'll just log them out. Use the effect console so we don't have to double wrap this. And maybe let's make it more interesting by opening up the console over here. And then we need the layer. So Google generative AI client.layer config. We've got an API key, so we can specify it with config.redacted Google API key. And then we also need an HTTP client. So we can just use the node one. Layer.provide. Let's import layer. Now this layer should be good to go. Yes. And now we can do program.pipe, effect.provide, main layer, node runtime. We'll use the node runtime since we already are importing node, run main. npm tsx scratchpad Google AI. The requested module does not provide an export. Google, did I not save this? No, I did not. Save. 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 Cool. Big error. So we got a parse error on the encoded side. Encoded side transformation failure. Expected a read-only array of generate content response. Actual is a chunk. What am I doing in here? Did I do something dumb? Chunk from self. So the chunk schema, the encoded side is an array. So if we look at schema.chunk, if we go in here and actually look at it, it transforms from an array on the encoded side to a chunk on the decoded side. But if we just use chunk from self, which basically says that both sides are a chunk, then it's fine. So this should now work. Hey, cool. So we can see our dad joke getting generated in here. Maybe we'll do console.dir depths null, colors true. Then if we rerun this, cool. We can see all of our responses coming through. Generate content response. We've got the content. Why don't scientists trust atoms? Because they make up everything. Nice. Cool. So really at this point now, there are two more things that we need to, well, there's one more thing that needs to be done on the client side, which maybe I'll do tomorrow. So if we go back to the, Google Generative AI client. So the first thing that needs to happen over here, we have this stream request method, but we also need the corresponding stream version of this, which takes the raw response, which is this, right? We have generate content response. This is like the raw response that we get back from Gemini or whatever model we hit on Google. And then usually most of our clients that end up doing this expose a corresponding stream method, which massages the data into AI responses instead. And I'm actually thinking about changing it so that instead of streaming AI responses, we stream parts of AI responses. But that's like kind of the unified data model that we use in the base AI package. This AI response type is like the unified, it basically allows us to take all the providers and shove them into the same like data model for responses from the provider. So that's the last thing I think we need to do on the client side of things. And then we can actually start looking into and then we can start looking into 1 second. We can start looking into implementing like the AI model side of things. But with this, we're in a really good place because streaming is oftentimes one of the more annoying pieces to get right from the provider. So yeah, I really want to know if the redacted names are working. Let's attempt to leak my API key. Maybe give it a bad model name or something. Effect.tap error cause log error. That's concerning. We are using the filter OK client. I feel like we should be getting an error here. We're hitting a URL that like doesn't exist. Does curling a URL that doesn't exist also just fail silently? No, I get a 404. Filter status okay. Maybe it's the double unwrap or something. I'm really not sure what's going on here. I'll have to look into this. The client is HTTP. Oh, where? Oh, it is. Sure is. HTTP client. Man, I need chat pair programming every day. This is great. Predicate is not true. Yep. You are 100% right. Let's see. Are we going to get 2 errors now? We should. Cool. Response error. So to get rid of this one, we go back to the scratch pad. Oops, scratch pad, Google AI. Effect.catch tag. Let's catch specifically the request error. Log. Log error. I want to see if my API key is being redacted. Oh, it's a response error. None 200. Right. Shoot. Response. No, my key is leaked. All right. Well, now I'm going to have to rotate my keys. That sucks. Why is that not working? Well, I'm gonna go delete my key now. Google. Well, I'll have to figure this out tomorrow. I have other work I need to get to, but I feel like this is pretty good progress. We've already got streaming set up very nicely. We just need to now massage the data from the Gemini response type or the Google response type to our own response type, and then we can implement an AI language model, and then we'll basically have the basic part of a provider for Gemini done. I'm actually surprised at how quickly we got to this point. But yeah, I hope you folks enjoyed the stream today. Thank you for your help. Looks like you and Dylan aren't that different, both leaking keys. Always. Right when Mattia wants an API key. Perfect. Yeah. Still logging the error before redacting? Am I? I don't think I am. Let's double check that before we sign out. Then we'll raid somebody. Google. So maybe I need to redact it as part of the stream. Let's do that. Stream locally there, or maybe we need to set it here. No, I have a feeling it has something to do with the streaming piece of this. But like ideally, actually, I wonder if I can do this yield effect locally scoped headers that because in reality, like we want this to live for the duration. Oh my god, why can't I v inner parentheses? Thank you. In reality, we want this to happen for the duration of this. Like if this layer exists, we want it to like dot scoped. So we're going to change these to scope layers. Locally scoped with. Is it meant to say Goog API? Yeah, it is. X Goog API key is the correct syntax. Yeah, I don't know why. Maybe it's because I'm like console logging it. I forget when redacted names get applied. You know what we could actually do really quick? We could set up a quick. God, I don't know what's involved in this to do it quickly, but we'd have to go to the scratch pad. You can set up telemetry really quick and see if it's redacted in the because it might not get redacted in the errors, which to me seems like maybe a little bit of a bug, but if it's redacted in telemetry, then we at least know it's being redacted somewhere. Const telemetry layer equals node SDK dot layer. Exporter. No. Metric reader, span processor. We want simple span processor. Or test your transform client and log the request. Yeah, I'm not like again, I'm not sure if the redacted stuff is going to happen there because we're basically doing the same thing. We're logging the request and the error. I think redaction may only happen like for telemetry purposes, but let's console span exporter. We're going to need to install a few things temporarily. So you guys, even I reference the docs. What did I want again? Chasing. And installing dependencies. We want this. And then we can do this. Oops. I want a simple span processor. I think there's still a few packages I need. Layer.provide telemetry layer. But if we fix this now, Gemini, we fix this now. npm. What was that? TSX. This should export everything to the console unless I'm missing a package. Yeah. So these content responses. Hey, there we go. Yeah, so redaction is working. I just think that it's not redacted when you log the request to the console directly. Probably so that we can. It's probably because these redacted things are literally only applied for spans. Like inside the response, it can't be a redacted value inside the request or the response, because if it was, then like we couldn't send the request or the response, I guess. I don't know, but if it's being redacted inside tracing, this is really where we want to make sure things are getting redacted properly from an HTTP perspective. Because inside here, this response, the headers are just a plain object, I think. Yeah, it's just an incoming message. Effect.log error should redact it. I don't think so. Not if an HTTP client response is just extending incoming message. There's no way for us to have a redacted header in there. And we could also even look to see where current redacted names is being applied. So it's being applied in middleware. Let's look at what's going on inside this test. Client request redacts headers. So we create a client request. We set the fiber refs. Inspectable to string unknown. So if I effect dot log error, it will redact it, you think? Oh yeah, you're right. Shows what I know. Which shows what I know. Yeah, you're right. It redacts it if you use the effect logging methods. For console log, it again makes sense that we can't redact it because inside the effect logging methods, we do, I think, use the inspectable module, which allows us to redact things we're supposed to. But the console module, in effect, literally just redirects to the console. So that's like for debugging purposes. All right, well, that's good to know. It's also good to know that this is indeed being applied. Cool. Well, then I think we're in really good shape for tomorrow. Let's npm remove these. And then we can get rid of the telemetry layer. Cool. Well, thank you all for, don't forget to rotate your key. No, I won't. I'll be rotating that key the second I sign off. Use it while you can. All right. All right, folks. Peace.